Okay, now we're talking about the concurrency of perpendicular bisectors. Remember, hopefully you got this definition down. Concurrency just means this is the point where the lines, certain lines intersect with each other, the point that they have in common. In this case, if we were to have a triangle and we were to draw three perpendicular bisectors, one for each side, they're all going to cross in one particular place. And that place is called the circumcenter. So the reason why it's called the circumcenter is because each point, or I'm sorry, the circumcenter is going to be equidistant from all three vertices. So in other words, in this picture, we want to find the point that's the same distance away from points A, B, and C. So literally what you do, and I'm not going to go through the process here, but what you do is you find the perpendicular bisector for each side and then find out where those three perpendicular bisectors cross. And that would give us a distance that where the distance from A to the center and C to the center and B to the center will all be the same. And I'll show you what that looks like. So again, find a location that is equidistant from A, B, and C. And in order to do that, you would draw a line that is a perpendicular bisector here. If you notice, D is perpendicular to A, I'm sorry, this line right here is perpendicular to AC and it cuts it in half. This line right here is perpendicular to AB and it cuts it in half. And this line right here is perpendicular to BC and it cuts it in half. Now, the three lines that they say are equal here will be this line right here. I'm going to use a different color. No, that's a good color. That's actually, I'll use green. Give me one sec. So let's make that green. And then this distance right here and this distance right here. So literally AD is equal to BD and that's equal to CD. So all three of those distances are equal. And the reason why they call this a circumcenter is because I can draw a circle with a center at D that will connect A, B, and C, and I'll show you what that looks like. So literally, if I measure out the distance from D to A, I can then draw a circle, and it's pretty close, but that connects all three of those. Okay? It should be right on C and right on B and right on A. So that's why, if we look at it carefully, we can state that 1, 2, 3, 4 is equal to 1, 2, 3, 4 is equal to 1, 2, 3, 4. So those three lengths are the same. Alright. And again, this is just explaining how you would do it. You can use a ruler and a protractor, or we can do it with a construction, which hopefully we'll have time to do in class. This is just the same type of problem. Again, we want to know what the circumcenter is. So if you were to do this, it would look something like this. And again, let me draw. If we call this D right here, we would know that AD would be equal to BD would be equal to ED. So all three of those lengths would be equal. And again, if I put one center there and put that there, I can draw a circle that connects all three. Okay? And that's it. Thanks.